Okay, so welcome to day 3 of the Mars Society's International Design Competition. When we last spoke, we were talking about water on Mars and the importance of finding water for many reasons. One reason is if humans are going to be there, they're going to need water because we need lots of water every day to survive. And if we find water on Earth, as I stated previously, we find some type of life. So this is an opportunity for humans to have a sustainable set of living conditions on Mars if you find water, but it's also a great opportunity for science because if we find living organisms on Mars, as Dr. Chris McKay has said many times, we may find a second genesis of life, which is extremely important to science and the world that we live in. Okay, so when we have our base camp, when we go to Mars, these are some of the options for powering our station. So there's no electricity there. So when we get there, we will have to have a way to power our computers, our life support systems. We will definitely have to be able to keep our habitat pressurized because the atmospheric pressure on Mars is very, very slight, about 1% that of Earth's. So we have to keep our bodies intact and we have to be able to produce oxygen for our habitat and for our spacesuits. And so a couple of options are solar power, which you guys probably are all very familiar with solar power, photovoltaic cells on solar panels. They're pretty much everywhere in the industrialized world now. Geothermal power, now that would take probably a little bit of time because we would have to find a place underground that is producing heat to make a geothermal power plant. And wind turbines. So there's again 1% of the atmosphere on Mars, so we're not sure how efficient this may be because of the lack of atmosphere. There is wind, it's just 1% of the wind compared to what it would be on Earth. So these are some options for you to consider. And if you have another option you want to use in your report, that's perfectly fine. It has to be reasonable. It has to be something that is in the process of being invented or has already been invented. Don't use something in your report that's completely fantasy. This has to be based in real science. If it's not 100% approved and invented and working now, that's okay as long as we're in the process of inventing this, whatever new power system you may come up with. And let's see, I have a question. Leo, great question. If it is geologically inactive, well, we do not know for sure that it's completely geologically inactive. Look up the InSight mission. The InSight mission was a Mars quake detecting lander that was on Mars for a few years. I believe the mission has stopped now, but it did detect many, 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 many Mars quakes, which indicates there's something going on underneath the ground on Mars. So look that up and you'll see they've made a lot of discoveries in that area. So scientists from 30 years ago often thought of every planet except for our planet because we live here. They often thought that every planet was dormant and there was nothing going on, right? It was just a ball of rock. And that's why exploration is important because it's not just a ball of rock. It's got a lot of dynamic things happening under the ground. And now because of the InSight mission, we know that. Internet access. So we'll need internet access. We'll need communication. We'll need a way to get information from Earth to Mars. We'll need a way to get information from Mars to Earth. So there is about a maximum of a 20-minute time delay if you wanted to call home, but you do have to be able to get information back and forth. I think probably internet access would be pretty simple since we send signals to Mars and to power, not to power, but to communicate with the rovers and landers using the orbiters. So there are orbiters at Mars now that will take the signal from the ground up to the orbiter and then send it back to Earth. And this is how communication will likely work, unless by that point we have some kind of fancy quantum computer. But for now, that's what the plan would be. So you need to be able to communicate and share information and deliver, scientific results. We taught.
The current satellites enough?
Pardon me?
Are the current satellites, communication satellites, enough?
I would say for an initial mission, they may send a special satellite just for human communication, but I think what is there is probably capable of, a good bit of communication. For example, Dr. Stephen Squires, who was the principal investigator of the Spirit and Opportunity rovers in 2004 when they landed, they weren't programmed before they flew to Mars. And you can watch his talk from the Mars Society convention. He was our keynote speaker and he told this whole story. It's on our Mars Society YouTube channel. And he said there was no basically information in the brains of the rovers. When they flew them, they only had very few commands on board. They had to design the commands and send them to the rovers while they were on their way. So if that was the case 20 years ago, before any of you guys were born, I'm sure we have the capacity to use the satellites that are there now to do some basic communication. I'm sure it would be great if we had something updated by the time humans got there, but your mission, you're not in charge of that. Yes, Tanae, you may use the existing orbiters in the report. Yes, you may use all of the existing, anything that's already in existence, you may use that in your report. So we talked about the weather and atmosphere last time. It's cold and windy. It doesn't rain now because of the atmospheric pressure, but it does snow in some areas. And the dust storms can last for months and they may interrupt communication, transportation, and safety of the habitats and vehicles. And we talked about the warmest it gets is about 20 Celsius, 70 Fahrenheit, but it gets cold at night very quickly because of the lack of atmosphere. So this is, Dr. Robert Zubrin calls these the tuna can habitats. So these would be something that is an idea for an initial landing. You may have something like this because it would fit in a cargo bay of any spacecraft. If you watched the big rocket launch last week from SpaceX when they were testing Starship, these would be great circular habitats that you could put in a cargo bay of a large rocket. And when they land, the first one on the left may have landed last year, and then the second one on the right may land 2 years from now. And then you connect them, and then you get a bigger and bigger habitat. This is just an initial possibility. Doesn't mean this is what you have to use for yours. You can also think about inflatable habitats. Inflatable habitats, you could take a much bigger habitat with you to Mars if it was inflatable, because it will fold up and collapse in the spacecraft in the cargo hold. So these are different ideas for you to think about. 3D printing will be a big deal on Mars. We already have many people planning on how to do this. You could use the regolith on Mars with a little bit of, whatever they make cement out of. I'm not a cement expert. And you can see there's very little here to this machine. You can see the structure of the machine, not the structure of the home they're building here. The structure of the machine is quite small considering what it can create. So 3D printing will occur. Are there any downsides to using inflatable habitats? I'm sure there are things like if there's a dust storm and a big rock comes through and punctures it. So that's why redundancy of life support systems is important. So say you have a habitat that gets punctured because it's made of fabric, a super strong fabric. You probably need a couple of different places to go so you can survive. You know, maybe I'll let you guys figure that out. I don't want to give you all the answers, but it's up to you to think about what would happen if you had an inflatable habitat and it did get punctured. Because if you're going to have machinery outside of the habitat, solar panels, a rover, things like that, and a dust storm picks something up and it slices through the outside of your inflatable habitat, do you have some place to go to survive until you can repair it? If you guys have seen the movie The Martian, that's a great start. It's actually based on Dr. Robert Zubrin's book or his plan, the Mars Direct Plan. So I would watch that with your parents' permission. So this is what, if you sent several spacecraft over many years, this is an example of what it would start to look like on Mars. If you think about it, these little pods that you see aren't all going to land in this nice, neat row. So if you wanted to do something like this, you need to think, how am I going to get all these little space pods turned into a habitat in this one nice, neat row? They would have to be moved there. How would you do that? And you can see the solar panels and the rover. Water, we spoke significantly about water last week. Food, how would you get food? Would you bring your food? Would you grow your food? We know that I call it soil here, but it's really regolith. It's not technically soil. We know that there aren't enough, mineral elements in the regolith on Mars that plants could grow. They have simulated this here on Earth. We know that building a greenhouse would be very important if you wanted to grow your own produce. You probably wouldn't be able to take a cow with you. So all your meats on your initial journey, if you eat meat, would be freeze dried. So think about food. Think about the psychology of food as well. I had a group at about 2 years ago. I do this in schools as well. I had a group who decided to only take algae with them for this whole trip, 6 months there, 7 months there, 18 months on the surface, and 6 or 7 months back. They were just going to grow algae. Think of eating algae for 2.5 years every day, 3 meals a day. Think of how that would affect your mind. Think of the best meal you've ever had and how you always wish you could have it again, and how happy it makes you to have something so delicious and wonderful. So think about food and how it affects people when you decide what kind of food you're going to bring. Travel. So here are some NASA mock-ups of rovers and how those would work. You're going to need a way to travel from the habitat to do science. How much of a rover are you going to build? You can't just walk 10 miles in one direction and 10 miles in another direction. It's going to take up a lot of oxygen, a lot of energy. It's going to burn a lot of calories. Think about what kind of vehicle for human transportation, and are you going to have any kind of rover or any kind of scientific equipment like that? The top 10 things you're going to need: food, water, houses, vehicles, energy, entertainment, communication, work to do, comforts of life, and personal items to remind us of home and family and each other. So there's a huge component of psychological factors when you're talking about sending people on a spaceship for 6 or 7 months in very close quarters. And then land them on a barren planet where there's nothing, there's no mall, excuse me, there's no mall, there's no restaurants. You just can't go to your mom's house whenever you want. think about the importance of the relationship of the crew members and how the crew members need to be able to think quickly to decide if something goes wrong. You need to have somebody that's going to decide something to help keep you all alive in many cases. So think about that. So this is a duplicate. We talked about this already. Oxygen, we need to have oxygen. The Perseverance rover that is now on Mars has a scientific piece of equipment called MOXIE that is taking out the atmosphere of Mars and separating the carbon dioxide and other elements in making O2, which is diatomic breathable oxygen. You will also be able to get oxygen from greenhouses because plants breathe in carbon dioxide, which is abundant on Mars, and breathe out oxygen. So this is very important. You have to have oxygen to breathe. So you're going to have a way to get oxygen. Creating an atmosphere. So this is long term. So if you were going to stay there long term, you would have to think about how to create an atmosphere if you want to terraform Mars. Heat, again, solar, geothermal, or wind turbines. You have to have heat because it gets cold. So think about that. Gravity. So the gravity on Mars is 1/3 of Earth. We know when astronauts go to space, they lose a lot of muscle mass, which causes bone loss. So you have to really have a very important exercise program, because if you ever want to come back to Earth and you've lost a lot of your bone and muscle mass, you're going to need some help. So you have to exercise a lot and very regularly. I believe they exercise on the International Space Station 2 or 4 hours a day. And sometimes they're only up there for a few months, and this will be about a 2.5-year journey at max. So you're going to have to keep your muscles and bones healthy and strong. So why do we want to go to Mars? For the knowledge of Mars, for the knowledge of Earth, because the more we learn about other planets, we learn about our planet. For the challenge, for the youth, for the opportunity, for our humanity, and for our future, because Earth is getting overcrowded and running out of resources. And so if we can take people to another planet, we'll be a multi-planetary species. And I like to say that humans to Mars as a bridge to the stars, because our sun will not survive forever. I mean, it has about, I don't know, 4 billion more years that it will keep Earth safe and cozy. But if we want humanity to survive, we need to learn how to live on other planets so we can go find other planets around other stars in the future. All right, here are the list of the rovers and landers we're going to talk about briefly, very briefly. These are just little bits of information. Viking 1 and 2 landed in the mid-70s. Mars Pathfinder and Sojourner rover was 94. So there was a long 97. I think it was 97. There was a 97 for sure. There was a long period of time before we landed something successfully on Mars. Spirit and Opportunity, 2004. Phoenix, 2008. Curiosity, 2012. Perseverance was just a couple years ago. The Viking 1 and 2 both had an orbiter and a lander. These are some views from where Viking 1 landed and Viking 2. You can see the little scratch in the soil there. It had a little arm with a scoop to scoop up the soil. And the reason it was scooping up the soil was they had several life detecting pieces of equipment on the Viking landers. This is an incredible story. I've written extensively about it. Many people have. And they had something called the labeled release experiment, which was invented by Dr. Gil Levin. And his experiment detected life on Mars. But there were 2 other experiments that were negative for life. So he believed, until he passed a couple years ago, that he discovered life on Mars, and many scientists agreed with him, but many scientists disagreed with him. So I highly recommend, if you're interested in that, read up on the labeled release experiment and the Viking landers. They have not sent any specific life detecting equipment to Mars since then. This is the Pathfinder and Sojourner rover. So this was a two-part piece of equipment. You can see on the left, it folded up like a little triangle, and the little tiny rover was in the middle, and it landed with those big airbags. And it was successful and lasted much longer. I think it lasted, I want to say 5 months, and it was only supposed to last like 14 days, something like that. It lasted a long time. It was the first successful rover landing and movement on Mars. Here's a top view on the left. You can see the panels or solar on the lander. And then on the right, you can see the rover. The airbag kind of stuck over the side here, and they had to make certain maneuvers to make a successful roving of the rover. And I think, I want to say it went 10 or 15 meters in total. It went really slow. And this is the panorama of where that landed. It's quite beautiful. It was planned for 1 month. It lasted 3 months. It measured the atmosphere and the dust and chemical analysis of the soil, and found that rocks were consistent with floodwaters, and found round pebbles, and traveled 50 meters. So that was 97. So 26 years ago, 27 years ago. This is how Spirit and Opportunity launched. It has Marvin the Martian, which I love. I don't know if you guys know who Marvin the Martian is. It's an old cartoon. And this is the launch vehicle. So the rover's way up here in the tippy top. The rest of this is all fuel. And it's very dangerous and risky to launch big rockets because sometimes they explode and destroy everything. That's why they wanted to launch two. And the mission was follow the water. So the whole point of Spirit and Opportunity was to find evidence of past water. And you can see here, this is a superimposed picture of the rover on the background, but the background is actually on Mars. You can see these little round pebbles. Those are called hematite, and hematite only forms in standing water over a long period of time. Spirit and Opportunity landed 3 weeks apart. Also using the airbag method, which you can see here, the airbag deflated, and it was also folded up, and the rover was folded up inside and unfolded and drove off. And Opportunity lasted, gosh, I want to say 12 or 14 years. They were only supposed to last, I want to say 30 days, 90 days. And they lasted for many, many, many years, way beyond what they were supposed to by many years. They are managed by the Jet Propulsion Laboratory in Pasadena, California. Here are pictures of Phobos and Deimos. Phobos is the larger light colored object in the picture on the left, and Deimos is the smaller one in the picture on the left. Those are the moons or natural satellites of Mars. Here's a beautiful picture of the sunset on Mars. I love showing these pictures because it gives you a sense of awe and wonder that this is another world. It's a world that we can inhabit. We just have to have the will and the moxie to do so. Here's Opportunity leaving Eagle Crater. Again, this was like, it landed in this perfect little, they call it the hole-in-one shot because it landed in this perfect tiny crater. And on the ridge of the crater, there are all of these layers that they could look back in time on Mars without having to dig, which was quite wonderful for their discoveries there. Then in 2008, Phoenix landed near the North Polar region. If you look at the picture on the upper left, the blue dot, you can see where Phoenix landed, very close to the North Pole. And the picture lower left is when the solar panels had deployed and were getting energy from the sun. In the lower right and upper right, you can see the parachute. So they had pictures, they were taking pictures from the satellites. That they could see the parachute deploying. The parachute is like the most important thing to slow it down so it can land safely. And it landed safely. And this is obviously an artist rendition of the landing. And you can see these reverse thrusters blowing the dirt away. And do I have it on here? There's a famous picture of looking underneath because they had a camera underneath. You can see the ice underneath the dirt or the regolith on Mars beneath the Phoenix landing site. So they landed. This is like just a bit of dust and regolith over the top of a bunch of ice blocks. So if you look closely at this image, you can see these like squares, quadrilateral shapes. It's ice blocks that the dirt has kind of moved around and formed these geometrical shapes. Because ice, when it freezes, it expands, and when it melts, it shrinks. So that's why these shapes occur. And here's the arm of the Phoenix lander digging up the soil. I showed you a picture of the sublimation from the ice from the Phoenix landing site last time. All right, Curiosity, the MSL, the Mars Science Laboratory Curiosity, landed in Gale Crater. Upper left is a overview of what the Gale Crater looks like, and the circle, the oval, that's where they planned on landing. They landed there because there were what appeared to be ancient riverbeds there, ancient areas where water would flow, and craters. If there was water flowing on Mars, a crater would be a great place to find evidence of that, which they did. And so there's a topographic map of the same thing. This is a very important image. So we have on the bottom, so we have these two guys in the middle, these two scientists. The small little rover, that's the Sojourner rover that landed in 1997. The one on the left, that's the size of Spirit and Opportunity. So not too big, reasonable. The one on the right is Curiosity and Perseverance and the size they are. So they're about the size and weight of a family SUV. So they couldn't use the airbag method. They were too heavy. If they would have used airbags, the airbags would have exploded on impact because it's just too heavy. So they had to do this amazing bit of engineering, and everything had to work one thing after another perfectly. So we have a heat shield protecting from the atmosphere when it comes through, and then the parachute to slow it down. But that wasn't really enough. We had to have this heat shield separation, back shell. Then you had to have a powered descent, which is, you know, the thrusters coming out of the bottom to slow it down. But then a sky crane, which was a new invention, and it worked beautifully. And the sky crane not only had to lower down the rover on a cable, it had to detach at the right point and fly away. So these are amazing bits of engineering you should be aware of. And Perseverance used the same system when it landed a couple years ago. Amazing, amazing, amazing. The amount of engineering that went into that is incredible. And the fact that it worked twice is unbelievable. And all of this whole back of the MSL, the Mars Science Laboratory Curiosity, all of this science equipment, all kinds of different, it's a science lab on the back of a rover, and both Curiosity and Perseverance have them. Perseverance is a little updated from Curiosity because there was about 10 years in between them. So we slowed from 13,000 miles per hour to 0 in 7 minutes. They call it the 7 minutes of terror, and it worked, and it was great. And so here's the sky crane. And now the Perseverance looks almost identical to Curiosity. It landed in Jezero Crater. So you see the Jezero Crater, the landing site here. These are wonderful images. This is the upper right, the picture with the red and white, that's the parachute. So that's a picture looking up from the rover as the rover's descending. The picture on the main right is the rover from above, from the sky crane, looking down as it's landing on the ground. And you can see middle right where the dust is moving from the ground, it's blowing away the regolith and landing perfectly. Beautiful, amazing feats of engineering. Is there an advantage to landing in craters? Yes. The advantage to landing in craters is craters are pre-dug up sites. So when you have a crater, something natural has already come around along, a big rock has come along and made a dent in the surface and dug a big hole. So I don't know if kids still go outside and dig holes, but back in the day, we always went outside and were like digging holes and looking for things, people who were interested in nature and science. And the thing is, there's no humans there to dig a hole, and you're not going to probably put a big shovel on a rover. You just put a little scoop. So it's a pre-dug hole. So as you look at the side of the crater, you can see the layers of sediment and rocks and what is in there. So instead of having to dig, you just drive your rover up to the edge of the crater and you can see what's there and examine it. One of the coolest things about Perseverance is the Ingenuity helicopter, which flew, I want to say 50 or 60 flights. It was only supposed to fly 2 or 3 flights. They didn't know if it could fly. It's very small, smaller than the size of a shoebox, and it flew and flew and flew. So this proves that it is possible for engineers to allow for flying machines on Mars for exploration. So this is another option for your human mission. If you want to do some recon and find a great place to drive your human rover to go explore, you can send out some little helicopters or drones, as kids nowadays have little drones, they can fly around and take pictures. Same kind of concept. Send your helicopter or drone out, do some research and see, oh, where's a good place to land? Great idea. So here are a bunch of the scientific equipment on the back of the Perseverance rover, including MOXIE, which produces oxygen from Martian carbon dioxide. And that is the end of the slideshow. If you guys want copies of these slideshows, I am happy to provide them to you.
Yes, please.
Okay,
Yes, where can you provide them?
I'll email them.
Oh, okay.
Was this purely a technology demonstration for future missions, or did Ingenuity? I believe Ingenuity was just for just to see if it'll work, because they didn't know with the thin atmosphere if they could fly. So the propellers go the opposite direction. So instead of them all going this way, they go opposite of each other. It probably helped the mission in scouting once they realized they could fly it over and over. But as far as did it have a mission designed specifically to find out science, I believe it was just to see if it would work. Okay, anything else?
Apart geology and searching for life, what are some other scientific observations that a crewed mission can do on Mars?
Well, you could do astronomical work, so astronomy. So astronomy on Earth is the oldest science. There's different kinds of, well, I have it all. I have it listed in the, did you guys read the document?
Yes.
The rubric and syllabus. Here, I'll bring it up. Geology, climatology, that's important. Study the Mars quakes. Paleontology, is there past life? Are there any fossils of past life? Is there present life, which you already mentioned? Resources for future use, precious metals. eventually, if enough people live there, you'll have to mine your own precious metals because you know, flying them from Earth is going to take a lot of resources. So, you know, history of the planet. There's a million different options. It's a whole planet, so you can imagine the possibilities of what you can find there and what you can find out. But isn't everything essentially science? Any kind of discovery is going to be science, right?
Thank you.
You're welcome.
In the Mars Direct plan,
Mhm.
Robert Zubrin mentioned having methane powered or chemically powered rovers, but anytime I try and look up rover design, it's always electric rovers.
You cut out
Do
at the
you have
you're cutting.
resources on powered rover design?
Can you repeat it? You cut out and
In the Mars Direct plan, Robert Zubrin mentioned chemically powered rovers, like powered by methane and oxygen or something like that.
yes.
And anytime I try and look up all electric rovers, do you have any resources
I will
concerning chemically
I will
powered rovers?
I will find the resources and I will send them. So non-electric, right? Is that what
Yes. Yeah, exactly.
Okay.
And like non.
Non-RTG.
Thank you.
You're
Yeah.
welcome.
Thank you.
You're welcome. Anything else?
Ma'am,
Yes.
regarding the team, um, so some of them are joined as a group.
Mhm.
So how many members are there?
So if everyone agrees to be in the group, it'll be 4 people, which is plenty to do the whole report.
Okay,
Okay, I'm just waiting to hear back from the other students.
okay,
Okay, otherwise it'll be 2 and 2, but you guys will have to decide because that's going to be a lot of work.
yes.
So I'm just waiting. When I get all the emails, I'll email you right away and I'll let you know.
Okay,
But you and Leo can start working together because you'll definitely be on a team one way or the other.
yeah. Maybe Leo, can you share your email address? I missed it.
I did last
Yeah,
last week, right?
Yeah, please reshare it.
he sent you his email address last week. Did you not get it?
No.
It was in the chat.
Let me send it. Did you get it?